So in this video, we will going to discuss about the engineering materials. So these are mainly classified as metals and their alloys, such as iron, steel, copper, brass, and aluminium. And of course, the non-metals like glass, rubber, and plastic. So the metals is further been classified as ferrous and non-ferrous. So in the ferrous material, having iron as the main constituents, such as cast iron, wrought iron, and steel. And the non-ferrous metals where have the metal other than iron as their main constituents, such as copper, brass, aluminium, tin, zinc, etc. So then we need to select the engineering material. How to select the engineering material? What are the factors I need to consider for selection of engineering materials while you want to design? So the first and the foremost point is the availability of material. So that means the material should be available readily in the market. And the second point is the sustainability of the materials for the working conditions in service. So that means while during the working, the material should be able to sustain the what are all the working conditions which are going to come on that material. And of course, the last factor, which is the very most important, is the cost of the materials. So these are the major criteria or the major factors which I need to consider. So one is the availability of the material, second the working conditions of the material, that is the sustainability, and the third one is the cost. Now the next point is we need to consider the properties of the material. So the moment when I talk about the properties, the important properties are physical and dimensional properties of the materials, are electrical, such as the electrical conductivity, the thermal conductivity, density, specific gravity, melting point, color, size, and shape. So then the chemical properties of materials, such as composition, structure, and corrosion resistance, and the important mechanical properties such as strength, plasticity, and then ductility, elasticity, stiffness, resilience, toughness, malleability, and hardness. So these are the major properties which I need to consider. So one is the physical and dimensional, and the second one is the chemical, and the last one is the mechanical properties. So the next comes once we go a little bit deep into the mechanical properties. So for the first one is the elasticity. As the name itself indicates, it is defined as the ability of the material to regain its original shape and size after the deformation when the external forces are removed. So that means when the external forces are applied, the material will going to get to be deformed, and on the removal of the external forces, it should be able to regain its original shape and size. So this is what is the elasticity. The steel is the perfect elastic material, so which we're going to have within a certain elastic limit. So this is the general graph which will going to come for the stress versus strain, wherein we have from O to E, so A to A, and then this is the elastic property. Once you take the permanent deformations, then the material will going to enter into the plastic stage. So this from this figure, if the specimen is up to 1 to point A, well within the elastic limit E, when the load corresponding to point A is gradually removed, the curve following the same path of AO, and the strain completely disappears. Such a behavior is known as elastic behavior. So that means, so within this elastic properties from O to A, what happens? So when the material is applied with some external forces, the material is going to get to be deformed. So when you go to try to analyze with stress, try to plot with stress and stress versus strain, so you're going to get this is the particular shape when on the removal of the load. So what happens? The load which will on the removal of the load, the material is going to go for, it will go to the same path as OA. So this is how it will going to be on the elastic behavior. So once it comes to the next behavior is what is called the plasticity. So the plasticity is once it goes to the permanent deformation is called the plasticity. So it is defined as the ability of the material to retain the deformation produced under the load on a permanent basis. So it is the ability of the material to retain its deformation. So that means on the removal of the load, it will not going to be able to come back to the original position, but it will going to retain the deformation on the permanent basis. So these properties of this material is necessary for forging, stamping and images of coins and in ornamental works, wherein we want to pour the gold ornamental works, wherein the material is heated to the plastic range, and then according to the requirement of the shape and size, accordingly the ornamental work can be done. So the next one is the ductility. So it is defined as the ability of the material to deform to a greater extent before the sign of crack when it is subjected to a tensile force. So that means it is defined, so it will be able to drawn out to be a reduced a section into a thin wire. So that is the property of the ductility. So that means it will be able to change its shape. So before the sign of crack when subjected to tensile force. It must be strong enough and plastic. It is usually measured in terms of percentage of elongation or percentage of reduction in cross-sectional area of the test specimen. So as the elongation takes place, what happens? In the volume will going to remain the same. So then therefore the cross-sectional area will going to be reduced as the length increases. So that is the percentage reduction in cross-sectional area. So that is what is the ductility. And so the example for a perfect ductile material or the mild steel, aluminium, copper, tin and lead are the ductile materials. So the next is the brittleness. So the brittleness is the property of the material which shows negligible plastic deformation before fracture takes place. So there will not be having much plastic deformation, but it will going to have the fracture. So the very good example is the cast iron and high carbon steel, concrete, stone, glass, etc. are the examples of brittleness. Glass is an ideal brittle material in which stress strain curve in tension is essentially a straight line. So that is basically because once the material is have an impact and the external force is applied on the glass, immediately it will going to break. So that is the very good example for the brittleness. Then it comes with the strength. It is defined as the ability of the material to resist the external forces causing the various types of stresses without breaking or rupture. So it is defined as the ability of the material to resist the external forces causing the various types. So once it have resisting the external forces, what happens? The stress will going to be developed on the body or on the member without breaking or rupture. So that means before breaking, it will going to be produced. Based on the type of stresses induced by external loads, strength is expressed as the, suppose if the tensile force is applied, you are going to get the tensile strength. And suppose if you have the compressive force is applied, then it will going to become the compressive strength. And suppose if the shear is applied, then they are going to have the shear strength. So based on the type of stresses induced by the external loads, accordingly the strength is expressed. So it will be having either it is tensile or compressive or shear. The row and the further about the tensile, the compressive and shear, we will going to talk about those things in the further coming videos. The load required to cause the maximum stress divided by the cross-sectional area of the test specimen is termed as the ultimate strength of the material. So the maximum stress divided by the cross-sectional area will going to be the ultimate strength. So then it comes with the stiffness. It is a rigidity, or rigidity is defined, stiffness or rigidity is defined as the ability of the materials to resist deformation under the action of an external load. The modulus, so here it is the ability of the materials to resist deformation under the action of external load. So the modulus of elasticity is the measure of stiffness. So what is the resilience? It is defined as the ability of the material to absorb energy when deformed elastically and to release the energy when it is unloaded. It is just like something like the flywheel, what it does, where it will going to store the energy in one half of the cycle, and in the another half of the cycle it will going to release the energy. So in similarly here, the ability of the material to absorb the energy when deformed. So when the deformation takes place, it absorbs the energy. So when deformed elastically, and to release this energy when the forces are when it is unloaded. Resilience is measured by a quantity called Modulus of Resilience, which is the strain energy per unit volume within the elastic limit. It is represented by the area under the stress strain curve in the origin within the elastic limit. So this is the stress strain curve, wherein you will going to have the curve, and within the elastic limit, whatever you get the area, which is called the modulus of resilience. Then we have the toughness. It is defined as the ability to absorb the energy before the fracture takes place, and it is measured by a quantity called modulus of toughness, which is the energy required per unit volume of the material to cause rupture under the action of gradually increasing tensile load. So this is the modulus of toughness, where it will going to have the area within the till the fracture takes place. So that is the area which is enclosed in the stress strain curve. So then we will going to have the malleability. It is defined as the ability of a material to deform to a greater extent before the sign of crack when it is subjected to a compressive force. So the malleability is depends on, it's always referred to the compressive force which is or the compressive load which is applied to deform a greater extent before the sign of crack. This property permits the material to be extended in all directions without rupture. So this property is utilized in forging and hot rolling, etc. The most commonly used materials are lead, soft steel, wrought iron, copper, and aluminium. So then it comes with another property, which is the hardness. It is defined as the resistance of material to penetration or permanent deformation. So when you have the material which gets under penetration, if the material is able to penetrate, then the hardness will going to be ready. You are going to have less hardness. If it's not possible, then it will going to be having the more hardness. It's a permanent deformation. It embraces many different properties such as resistance to wear, scratching, deformation, machinability, etc. So hardness will always depends upon the machinability, the resistance to wear, and the scratching. As the hardness increases, what happens? The strength also increases. And also, test of hardness may be classified as scratch test and indentation test. And the scratch test consisting of pressing a loaded diamond into the surface of the specimen and pulling the diamond so as to make a scratch. So that means basically we use the diamond tip, and you make the diamond tip to be placed on the hardness of the material to be checked, and rub against that, pulling the diamond so as to make the scratch. So this is the indentation test consists of pressing a body of standard shape into the surface of the test specimen. So indentation is basically like Rockwell and Binek hardness, where we are going to bring the ball indentation to just to touch the surface of the material, and then we're going to apply the load. Then how much penetration it will going to be takes place inside the material of the specimen. Based on that, we will be able to decide about the hardness of the specimen. The example for that is the Brinell hardness test and the Rockwell hardness test and Vickers hardness test. So creep. When a member or a part of a machine subjected to a constant stress at high temperature for a longer period of time, it will undergo a slow and permanent deformation, which is called creep. So basically creep is depends upon the temperature. So when a member or a part of a machine subjected to a constant stress at high temperature for a longer period of time, it will undergo slow and permanent deformation, which is called creep. So the property is considered in designing IC engines, boilers, and turbines. So this is about the basic proper selection materials, selection of engineering materials, the factors to be considered, the mechanical properties which will be dealt with in detail. Thank you.